When you're adding and subtracting complex numbers, guys, you just have to look for your like terms. So what I was saying, what I make my Algebra 1 students do is I make them box and circle and underline like terms. So the real parts are like terms, and the imaginary parts are like terms. Just watch your signs is what I need you to do. All right, Emily, add the real parts together.
5.
Good. Trent, add the imaginary parts together. So positive 7 and a negative 6. What does that make? Positive 7i, negative 6i. Make how many i's? Opposite signs. When the signs are opposite.
7 minus? Oh.
Well, it's your addition rules that are right over there. That a positive plus a negative is the sign of the bigger number and subtract. You always have to take the sign in front of the number. So what do you get, Trent? Positive or negative? So positive 1i. And guys, you don't have to write the 1. That's fine. That's in true complex form.
That's all you have to do.
That's all you have to do. All right, next one, 3i minus parenthesis, complex number negative 2 plus 3i, parentheses, minus parentheses, complex number 2 plus 5i. Now, why what?
Oh, never mind, we're on B. I was going to say, why that time?
Oh,
5 plus 5.
how did it grow? Yeah. Okay. Now, personally, guys, I would never subtract. Okay. I always change the negative sign to addition, and then I distribute. It's like there's a negative 1 right here, and you're distributing it in there. So I change this to a plus, and inside the parentheses, I change sign. Change sign. Same thing at the end. I never subtract. I change this to a plus, and I change sign. Change sign. Go ahead, Harrison.
Why?
3i, negative 3i, and negative 5i are like terms. Anybody see the other two like terms? Raise, please. Anybody see the other two like terms? Raise. There's 2 more like terms here that we could add. Go ahead, Nick.
2 and negative 2.
Thank you, sir. Positive 2, negative 2. That sounds good to me. All right, let's add the like terms. Destiny, let's do the real parts. Positive 2 and negative 2. So we got 0. Okay. Alexis, M, do the imaginary parts. What's 3i plus negative 3i? 0. So those go. Plus a negative 5i. Very good. True complex form? Yes, it is. There we go. That's how easy adding and subtracting is. Next part, multiplying. Example 4 has 3 parts to it, though. Okay, letter A. Take the scalar 4 and multiply it by the complex number negative 2 plus 3i. Now, I know you guys know to do this property. Can we make somebody's teacher proud and tell me the name of that property? Don't yell it out, Race. Trenton? Or Trenton, Harrison?
Distributive?
Yes, and who was your teacher that taught you that?
Mr. Cole, sorry.
Oh, I'll tell him at lunch. What a good job he did on teaching you the distributive property. Okay. All right. Awesome.
In my private school, we do like
Dom, go ahead and distribute 4 times negative 2
Negative 8.
and 4 times positive 3i. What kind of 12i? Positive or negative? Okay. And Christian, is this in true complex form?
Yeah.
Yes, it is. Will you be done with A? Thus far. All right, complex number 2 minus I times the complex number 4 plus 3i. Think of these as two binomials. And the only way to multiply two binomials, gang? FOIL. I got Harrison in my gang. All right, first, last, inside, outside. Okay? Now, remember, you can FOIL whatever way you want to FOIL. You can FOIL, you can OLIF, you can LOIF, you can FLOI, whatever order you want to multiply the things in, it doesn't matter. I just am used to FOILing and multiplying in that order, okay? All right, Ariel, first times first, 8. Ariel, outside, outside. Do you want plus 6i or minus 6i? Yep. Ariel, inside, inside. Lovely. Ariel, last times last. Yeah, negative I times a positive 3i is negative 3i squared. Awesome job, thank you. Okay. All right, Christian, we got some like terms in the middle. So 8. So what's Christian? Positive 6, negative 4.
Positive 2i.
Minus.
3i squared.
Okay. Dom.
Wait, what did I?
What did? Shush, please. I'm recording. What did we put in place of I squared, Dom?
Negative 1.
Very good. Very good. Okay. All right. Let's finish this up. Do you have to write every single step? Not necessarily. If you can do some math in your head. Lexi, what's a negative times a negative? Okay. And then I think, guys, we have one more set of like terms. So let's go that way. Sydney, so final answer? 11 plus 2i. Sydney, is that true complex form? Yes, it is. We're going to be doing more foiling in a little bit. Letter C is the complex number 3 plus 2i squared. Okay? Now, this is the same situation I was talking about my prep geometry students on their test. They didn't FOIL. And they just squared each of these and said they were done. Well, guys, you can't do that. You actually have to do 3 plus 2i times 3 plus 2i. And I'm going to let you do that with... All right. Final part, guys. Example 5. Last part. Okay. What's left to do? Divide. Applications.
Can you
Don't
do
even talk about
applications, please?
Sure.
You can?
Mm-hmm.
How?
Wait, do they come
You
with
can't
applications?
apply imaginary things.
Unless you spend it.
All right. Now, here's the rule for dividing. When you divide, you multiply. That's confusing already, right?
Yeah.
When you divide, you multiply.
By the recipient.
The numerator and the denominator by the complex conjugate of the denominator. Okay, and I'll show you what the complex conjugate looks like. Okay, if the denominator is in complex form a plus bi, then the conjugate is You ready? You on the edge of your seat for this?
Yeah.
A minus BI. You're only looking at denominator. Complex conjugate of the denominator. This is kind of like when we used to rationalize the denominator, okay? We're trying to get rid of the complex number on the bottom of the fraction is what we're doing, okay? So that's the whole point of the process, is to get rid of the complex number on the bottom. All right, so let's divide. 2 plus 3i divided by 4 minus 2i. All right, Sam, what would be the conjugate of the denominator?
4 plus
Very good. And gang, what's the only way to multiply binomials? Foil. Okay, so we got to do a bunch of foiling. All right, Christian, do the like terms on the top.
2. So 2 plus 69.
2 plus 69, thank you, sir. Okay, and then Ariel on the bottom, 16 plus 4. Do you see how the complex number went away on the bottom? And we just got the number of 20. One more simplifying, make me proud, what is it? Pretzel, thank you very much. Now, you can use your reducers on your calculator, but we have to reduce 2 over 20. What is that, gang? 1 over 10. So on your calculator, you can do 2 divided by 20, math enter, enter, and get 1 over 10. Plus, and can you do the same thing? Cindy, don't say the answer yet. 16 over 20. Can you use your reducer over on your calculator? And what does that reduce to? 4 over 5. Anybody concur? Okay. So 4 over 5. And then at the end? I. Now, is that in true complex form? Yes, it is. How about that dividing?